4680 battery technology empowers Tesla Optimus with extended operational durations and accelerated charging capabilities, significantly enhancing user experience while minimizing downtime. This cutting-edge innovation effectively supports a variety of demanding tasks. In conjunction with battery advancements, Optimus's design incorporates a computing platform derived from Tesla's autonomous vehicles, which enables sophisticated functionalities such as visual inference and motion planning. This integration markedly enhances the capabilities and adaptability of the robot. Moreover, the transition from traditional battery cell configurations to the innovative 4680 cells serves as a testament to Tesla's dedication to improving energy density and optimizing production cost efficiency. This strategic shift is pivotal for the company's aspirations toward future innovations. Additionally, the tabless design of the 4680 cell allows for enhanced thermal management and superior current flow, which facilitates faster charging. This characteristic is essential for the performance of electric vehicles, contributing to overall user satisfaction. Turning our attention to healthcare, Optimus Gen 3 is specifically designed to assist in clinical environments by alleviating the workload of nursing staff, thereby potentially addressing the global nursing shortage. The robot's design prioritizes both safety and efficiency in patient care. Furthermore, the advanced AI capabilities embedded within Optimus Gen 3 enable real-time processing of medical data alongside the execution of precise tasks. These features are instrumental in enhancing patient care while concurrently reducing the risk of injuries among healthcare professionals. Optimus Gen 3's design incorporates sophisticated features, including 14 high-resolution cameras and 40 precision sensors, which collectively facilitate an impressive navigation accuracy of 97.5%. This technological sophistication significantly mitigates healthcare workers' exposure to pathogens in high-risk environments. The global nursing shortage represents a critical concern, with an estimated requirement for 5.8 million nurses by 2023, projected to decrease to 4.1 million by 2030. This shortage is particularly acute in low- and middle-income countries, underscoring the need for effective solutions. However, significant cybersecurity risks present a formidable challenge in the integration of Optimus within healthcare settings, as indicated by the fact that 44% of organizations experience vulnerabilities in 2024. Regulatory compliance also remains a substantial issue, with only 28% of robotic systems currently meeting established standards. The notion of degrees of freedom in robotics denotes the independent movements a robot is capable of executing, thereby enhancing its versatility for performing diverse tasks. This principle is particularly critical in the design of humanoid robots. Moreover, Optimus Gen 3 is anticipated to manage approximately 3,500 tasks, effectively doubling the operational capacity of its predecessor. This development signifies remarkable advancements in robotic functionality and precision. Finally, the incorporation of advanced AI algorithms from Grok 4 into Optimus Gen 3 further amplifies its versatility and precision, enabling the robot to execute more complex operations efficiently. Optimus Gen 3 incorporates sophisticated sensors, including cameras and ultrasonic depth sensors, which facilitate its ability to perceive and navigate stairs with remarkable efficiency. This cutting-edge technology significantly contributes to the robot's adept movement planning. Additionally, the robot's force sensors deliver real-time feedback that allows for precise adjustments in joint movements, effectively preventing slippage and ensuring balance during descents. This capability is critically important for the successful navigation of stairs. Moreover, the integration of Grok AI-4 significantly enhances Optimus's competence in understanding and responding to commands, thereby improving its contextual reasoning and spatial awareness. This advancement is particularly beneficial when navigating complex environments. Furthermore, the combination of artificial intelligence and advanced sensors empowers Tesla Bot Gen 3 to predict movements and maintain stability, distinguishing it from conventional rigid robots. This proactive approach markedly increases its adaptability to various situations. In addition, the Tesla Bot Gen 3 employs a sophisticated array of foot-mounted inertial measurement units, IMUs, and torque sensors to assess pressure and orientation, thereby mimicking the subtle micro-adjustments humans make on uneven surfaces. This technology significantly enhances the robot's overall balance. Dynamic balance is further refined through high-frequency physics simulations that evaluate potential movements, facilitating swift adjustments to maintain stability. This capability equips the robot to effectively manage challenging terrains. Moreover, the robot's ability to adjust its center of gravity not only enhances energy efficiency but also minimizes mechanical stress, thereby promoting long-term reliability in its operational functions. In light of future enhancements anticipated from Grok AI-4, it is expected that the robot's contextual decision-making will further improve, enabling it to adapt dynamically to various terrain types and environmental conditions. Lastly, Optimus Gen 3 demonstrates exceptional performance in indoor settings, owing to its thoughtful design, which allows it to navigate standard furniture and household obstacles with both ease and precision. The design philosophy of Optimus Gen 3.5 centers on approachability, deliberately steering clear of the intimidating aesthetics typically associated with traditional robots. Its sleek, human-like appearance fosters a sense of comfort, thereby facilitating more engaging human interactions. Enhancing this interactive experience, Optimus Gen 3.5 features an LED faceplate that significantly improves communication. This innovation allows the robot to express various emotional states, resulting in more natural interactions with users. Indeed, this upgrade represents a noteworthy advancement over prior models. With a targeted price point of $10,990, Tesla aspires for widespread adoption of the Optimus, strategically integrating it into a multitude of environments. This approach contrasts sharply with the luxury branding commonly seen in other robotic offerings. The design philosophy further emphasizes minimalism, which supports extensive customization capabilities. This framework enables Tesla to effectively adapt the robot's functionalities for specific applications without necessitating significant hardware modifications. Optimus comes equipped with specialized accessories tailored for diverse environments, ranging from industrial factories to elder care facilities. Such enhancements significantly bolster its usability and effectiveness across various scenarios. In addition, Tesla plans to offer cosmetic accessory packages specifically for commercial applications. This initiative allows the robots to seamlessly integrate into upscale environments, thereby creating new and lucrative revenue streams. The investment in protective gear for outdoor use Tesla bots, which ranges from $400 to $600, underscores the significance of additional accessories. These enhancements are crucial for ensuring optimal operational efficiency across varied environments. Tesla also provides digital accessories, including AI language modules and facial recognition software, priced between $500 and $800. Such features are likely to attract companies seeking to augment their bots' multifunctionality. Elon Musk has indicated a base price for the Tesla bot set between $10,000 and $20,000, reflecting promising profit potential from these customized accessories. This modular approach empowers Tesla to cultivate a sustainable revenue stream. Furthermore, mission packs for TeslaBot will facilitate task-specific customization, significantly enhancing its versatility for enterprise customers. This strategy is reminiscent of Tesla's practices concerning vehicle upgrades. The Gen 3.5 incorporates precision-engineered hands and the capacity to learn tasks, thus improving its efficiency in handling household chores compared to previous models. This advancement allows the robot to execute more nuanced actions. With its enhanced mobility and lightweight structure, Gen 3.5 can operate continuously while maintaining a high degree of precision. This capability renders it suitable for long-term deployment within residential settings. Importantly, the robot functions independently of constant internet access, attributable to the integrated full self-driving chip that processes data locally. This functionality ensures continuous operation during power outages or internet disruptions. Gen 3.5's ability to adapt its cleaning schedule based on human activity illustrates a sophisticated level of contextual awareness. This feature greatly enhances its usability for families and elderly users alike. Equipped with automatic charging capabilities, Gen 3.5 effectively maintains a high battery level throughout the day, enabling more flexible operation. This design ensures that the robot can address a variety of tasks without encountering frequent downtime. Moreover, Gen 3.5's capacity to remember specific user preferences and adapt its routines enhances the overall user experience, thereby eliminating the need for repetitive instructions. This level of personalization is critical for ensuring a seamless integration of robots into family life. The hardware architecture of Gen 3.5 supports dynamic learning capabilities, allowing it to physically sense and respond to its environment. In this manner, it acquires knowledge akin to human behavior through observation and practice. Tesla's strategic emphasis on personalization, rather than mere functionality, suggests that the future of household robots will heavily rely on their capacity to understand and address individual user needs and preferences. The lightweight design of the robot, coupled with its built-in full self-driving brain, enables it to learn and adapt through experiential processes, thereby enhancing its functionality over time. This ability distinguishes it from traditional robotic counterparts. Tesla's innovative manufacturing methodology, which employs gigapress technology, facilitates rapid production scale without escalating costs. This operational efficiency confers a significant competitive advantage within the robotics sector. Ultimately, the Optimus Gen 3.5's ability to perform a multitude of job functions while receiving over-the-air software updates ensures that it can transition between tasks seamlessly without necessitating retraining, contrasting sharply with the dynamics of human labor. The transition from mechanical aesthetics to a smooth, minimalist design represents a significant evolution in Tesla's approach to humanoid robotics. This strategic change is essential for the seamless integration of these robots into everyday life. Furthermore, the careful avoidance of the uncanny valley effect is pivotal in the design of Optimus Gen 3, as it effectively minimizes the mechanical sensation often associated with robots. This mitigation fosters a more favorable response from consumers. In addition to aesthetic considerations, Tesla aims for mass production of Optimus bots at a reduced cost, targeting an ambitious production volume of 10 to 20 million units annually. This audacious goal distinguishes Tesla from its competitors in the robotics sector. Moreover, the streamlined design facilitates rapid assembly through the use of industrial robots, which significantly reduces labor costs and accelerates the manufacturing process when compared to traditional production methods. In parallel, Optimus Gen 3's reduced weight contributes to enhanced energy efficiency, yielding substantially lower power consumption during operation, thereby improving safety in environments where vulnerable individuals are present. Beyond performance enhancements, the redesign not only elevates the functionality of the robot but also significantly boosts the brand value of Optimus. This positions it as a sought-after consumer technology rather than solely a robotic tool. To highlight the advancements, the Gen 3 design incorporates a simplified structure with fewer components, which enhances reliability and enables full robotic assembly, effectively reducing both costs and production time. In this context, Optimus Gen 3 leverages proven technologies from Tesla's electric vehicle division, resulting in notable cost savings and improved performance owing to existing supply chains and rigorously tested components. The latest iteration of Optimus achieves an exceptional 99% accuracy in executing complex tasks, which exemplifies significant advancements in artificial intelligence and mechanical design, thereby positioning these robots for effective collaboration with human counterparts. Tesla's reinforcement learning model further enhances Optimus's capabilities, enabling it to swiftly learn new tasks by observing human behavior. This innovative approach far exceeds traditional programming methods, facilitating faster skill acquisition. Moreover, Optimus 5.3 employs a self-correcting feedback system that allows for quick learning from mistakes. This critical capability ensures the robot maintains high accuracy during task execution. In addition, the robot's over-the-air software updates contribute substantially to the continuous improvement of performance. This feature allows Optimus to proficiently master a myriad of tasks throughout its operational lifespan. The introduction of Tesla-designed actuators significantly enhances torque and speed, providing refined control that is essential for delicate tasks such as handling glassware and performing laundry. This innovation distinctly differentiates the robot from conventional industrial models. Furthermore, Tesla's integration of a sensor fusion system empowers the robot to adapt its grip and movement in real time, which is crucial for effective operation in unstructured environments. This capability allows for precise interactions with a variety of objects. Additionally, the robot's sophisticated neural network enables it to make decisions based on contextual understanding rather than merely following static commands. This level of adaptability considerably enhances task success rates and overall performance. The Gigapress 50T represents a significant technological advancement, facilitating substantial reductions in parts count and production time, thereby enhancing consistency and lowering failure rates. This technology is crucial for the successful production of Optimus robots. In terms of manufacturing efficiency, Tesla's factory design employs a modular cluster model, enabling parallel assembly of various robot components. This approach effectively mitigates bottlenecks and optimizes robot utilization. Lastly, the Robot Builds Robot concept introduces the potential for each Optimus unit to produce an additional bot on a weekly basis, thereby fostering exponential growth in robotic capacity and significantly enhancing production efficiency. The new walking style of Optimus Gen 3.5 closely emulates human biomechanics, thereby facilitating smoother movement and minimizing energy expenditure. This pioneering approach distinctly sets it apart from earlier robotic iterations. Furthermore, the coordinated arm swings exhibited by Gen 3.5 enhance both balance and fluidity in motion, thereby fostering a more human-like interaction style. This particular design choice significantly augments the robot's functionality across diverse operational environments. In addition, Tesla's implementation of auto-simulation technology has permitted the robot to engage in extensive virtual training, effectively compressing thousands of hours of learning into mere days. This advanced technology substantially bolsters the robot's adaptability to real-world conditions. Moreover, The robot's optimized foot landing technique minimizes impact stress, showcasing a sophisticated understanding of biomechanics. Such innovation holds the potential to enhance the efficiency of robots in executing a variety of tasks. However, despite these impressive motion capabilities, there remain pertinent questions regarding scalability and the consistency of performance across mass-produced units. Manufacturing variances could significantly influence the qualitative aspects of the robot's walking capabilities. Transitioning to real-world challenges, factors such as wear and computational demands are pivotal in evaluating the long-term viability of the robot. Achieving effective responses in unpredictable environments continues to represent a considerable hurdle. The design of the charging stations features a streamlined architecture that facilitates docking while the robots remain standing, thereby enhancing operational efficiency and reducing wear on mechanical components. This innovation signifies a noteworthy advancement in the domain of robotic charging. Tesla's charging framework underscores a focus on simplicity and modularity, optimizing spatial utilization within industrial settings. This innovative design may enable the concurrent charging of numerous robots, effectively mitigating overheating concerns. Moreover, the incorporation of real-time fleet management software will prove essential in optimizing charging and maintenance schedules. Tesla's objective is to ensure the efficient utilization of each robot, thereby enhancing their operational longevity. The layout of Tesla's facilities closely resembles military barracks, suggesting potential applications in high-security environments. This strategic approach aligns with their recent recruitment efforts for specialized roles in sensitive operational areas. Furthermore, Tesla's design integrates advanced cooling systems to effectively manage heat generation. This feature is critical for sustaining optimal performance levels in robots that operate under high thermal conditions. Operational efficiency is further maximized through the implementation of a 3-shift rotation for robots. This strategic approach enables continuous operation while significantly reducing real estate and downtime costs. DreamGen harnesses cutting-edge video diffusion models to construct a simulated environment, thereby enabling robots to acquire behaviors without engaging in physical trials. This approach markedly improves the efficiency of the robot training process. Furthermore, the methodology facilitates zero-shot generalization, allowing Optimus to master intricate tasks without the necessity of prior demonstrations. This remarkable adaptability signifies a pivotal enhancement in the capabilities of humanoid robots. In addition, DreamGen's inherent flexibility permits it to function across a diverse range of robotic platforms, suggesting Tesla's aspiration for the development of a universal training system. Such innovation holds the potential to transform applications across various industries. Moreover, the DreamGen system empowers Optimus Gen 3.5 to engage in autonomous learning from synthetic environments, which confers a significant training advantage compared to conventional robots that depend on human guidance. Following the completion of its training in November 2025, Tesla's Optimus Gen 3.5 is poised for real-world deployment, thereby enhancing manufacturing efficiency through seamless integration within existing workflows. Finally, Optimus Gen 3.5's social adaptability enables it to collaborate effectively with both humans and other robotic entities, representing a substantial advancement in the realms of industrial automation and productivity. In addition to aesthetic considerations, Tesla aims for mass production of Optimus bots at a reduced cost, targeting an ambitious production volume of 10 to 20 million units annually. This audacious goal distinguishes Tesla from its competitors in the robotics sector. Moreover, the streamlined design facilitates rapid assembly through the use of industrial robots, which significantly reduces labor costs and accelerates the manufacturing process when compared to traditional production methods. In parallel, Optimus Gen 3's reduced weight contributes to enhanced energy efficiency, yielding substantially lower power consumption during operation, thereby improving safety in environments where vulnerable individuals are present. Beyond performance enhancements, the redesign not only elevates the functionality of the robot but also significantly boosts the brand value of Optimus. This positions it as a sought-after consumer technology rather than solely a robotic tool. To highlight the advancements, the Gen 3 design incorporates a simplified structure with fewer components, which enhances reliability and enables full robotic assembly, effectively reducing both costs and production time. In this context, Optimus Gen 3 leverages proven technologies from Tesla's electric vehicle division, resulting in notable cost savings and improved performance owing to existing supply chains and